Good morning. So today we're going to be graphing reciprocal functions. Don't freak out. It's a lot easier than it looks. All it means is that instead of y equals x, like a linear function, it'll be y equals 1 over x. So in HK form, it's going to look like a over x plus h, x minus h plus k. So we know that as long as the denominator, the bottom part, looks like x minus h, the h is a positive number because the sign doesn't change. It's a positive number. We're just plugging into this value. We know that if it becomes x plus h, that we've plugged in a negative number because the sign has changed. So before we get started, we're going to look at our h and k, and this is really important. So we're going to look and see that for our parent function, there is no a, it's just 1, right? The h, there's no h because it's not subtracting or adding anything on the bottom. So we know that my h is 0, and there's no k here, so k is 0. That's really important to know because this vertex is going to determine the asymptotes. So asymptotes are where the line approaches but never really touches. So I know that my asymptotes are going to be 0 on the y-axis and 0 on the x-axis. I know that was a little squiggly. But I know that my graph will approach the x-axis and the y-axis and will never touch them. So it'll approach, but it'll never touch these axes. So when I find where my asymptote is, I'm going to go 2 points to the right and 2 points to the left. So here I chose -2 and -1. -half just because it gives me a whole number, and then +half, 1, 2. So for -2 and -1 and +1 and 2, we know that when we plug it in, it either just gives us 1 or half or -1 or -half. But when we plug in -half or +half to x, it's going to look like that. So we know that whenever we divide by a fraction, we have to multiply by the reciprocal. So now I'm multiplying 1 times 2, which gives me 2. That's why I used half, so I would get a whole number in my y. So now we're just going to graph it. -2, -half, -1, -1, and -half, 2. So I know that even though it gets really close to this y-axis and the x-axis, that it'll never touch them. It's just going to curve. The same with half, 2, 1, 1, and 2 half. After that, half, it'll just keep getting smaller and smaller and smaller. Over here at 10, it'll be 1/10, but it still doesn't touch this axis. So it kind of looks like a butterfly a little bit. It curves this way and curves this way. We know that our vertex, or HK, or is 0, 0, and that because it is 0, 0, these asymptotes will never approach 0 on the x-axis or the y-axis. So we won't have an x-intercept or a y-intercept. Remember, we just put NA, not applicable, no answer. Because we know that our h value is 0. That's like our x and our y, right? HK. So x is 0 because it cuts it right down the middle here. So we're going to say that our axis of symmetry is x equals 0. Now our domain is really all real numbers. It goes to infinity all the way this way, and then it'll go, even though it skips 0, it continues to go on this side. So all we say, because we know it goes left forever and right forever, except for here, we'll say all real numbers except x, where x does not equal 0. That's it. For range, it's the same, because we know that even though here it goes up forever and here it goes down forever, it will never be here at 0. So we'll also say that our range, our y values, will be all real numbers where y, does not equal 0. Then our increasing interval, so for our increasing interval, we're going to look at the direction that these butterfly wings are curving. So here, even though it comes towards that 0, the axis of symmetry, it shoots down. So here it's decreasing. Here, even though it's pointing up here, as we leave this origin or the vertex, it starts to decrease. Even though it keeps going this direction, little by little, it's just fractions. It'll be decreasing, getting closer to this 0. So we're going to say that they're both decreasing. So we're going to say there's no increasing interval, NA. And our decreasing interval will be from negative infinity to 0, but it's never 0. And then we'll say, and then it continues from 0 to positive infinity. So again, remember, we read our graph from left to right. We've always done that since the very, very beginning. So when we read our graph from left to right, we see that as we come from the left side and we start approaching the vertex, that this decreases downwards. That's where it ends. It's ending going down, decreasing. Then we see here, because we have to skip 0, on the other side of 0, even though it goes up in this direction, as we leave the vertex and we continue to move to the right, it comes all the way down and continues to decrease until it gets so close to 0, it's 1 over infinity. So we know that both of these are decreasing. Just like the cubic function, we will either have a decreasing or an increasing interval. These will never be both. It's always one or the other. Our rate of change, if we look at our rate of change, it varies, right? From here to here, there's half. If we went and did 3, even though our x is decreasing by 1, our y would end up being negative 1/3. So from negative 1/3 to negative half is a different from the difference of -0.5 and 1. So we're going to say, just like the cubic, just like the parabola, that our rate of change varies. Is it a one-to-one? Yes, it is. Even though it may look like the tail of these are straight, they're not. They're decreasing, but they're decreasing ever so slightly. You just can't see it. So it really won't go through a horizontal or a vertical line will not go through twice. So it is a one-to-one, yes. Our minimum value, if we look here, it goes down forever. It never stops. That's what the arrow is for. So there is no minimum value, NA. And our maximum value, it goes up forever, right? So that never stops. So our maximum value is NA. You probably already caught on to that. The horizontal asymptote, you're going to look at the line that runs horizontal, which is our x-axis. So you're always going to look for your horizontal asymptote, you're going to look at h. And when we look at h, we see that it's 0. So we're going to say x equals 0. Then when we look for our vertical asymptote, we're going to look at our vertical line, which is our y. And we're going to look at k, which is our y value. And we're going to say that y equals 0. So going forward, the rate of change, one-to-one, our minimum and our maximum will always be the same answers. We will always say that the rate of change varies. It is a one-to-one. There is no maximum value and there is no minimum value. Now, transformation refresher. So we know, because we've been doing this all the way since October, that whenever we have a negative a value, it will give us a vertical reflection. When the absolute value of a, this is so important because I see you guys with an a value of -3, and you say -3 is less than 1, so it's a vertical compression. But it's not, because the absolute value of that -3 is +3. So that would put it in this section here. Very important to remember that when the absolute value of a is less than 1, then it's a vertical compression. It's not just the value of 1, it's the absolute value. Sorry, the absolute value of a. So when the absolute value of a is greater than 1, it is a vertical stretch. And then h, horizontal, h, horizontal shift. And k will give us a vertical shift. Whoa, vertical. Okay. Too many I's, too many letters in that vertical. That's why I teach math and not English. Vertical shift. Okay. So our steps to find the HK is very similar to what we've been doing this whole time. We know our parent function, we do the parent chart, identify A, H, and K, and then we write our new table as x plus h and ay plus k. And then we graph the new points and find all characteristics. The first thing we're going to do when we graph this function is to find our A, H, and K. So remember, it is A over X minus H plus K. So because our 1 hasn't changed, our A must be 1. H is 2. Remember, positive 2 because our sign hasn't changed. And K is 5. So I know that my HK will be here at 2, 5. Now you don't have to mark them, but it's nice to mark them just to know which points not to use. If you were to not mark your asymptotes and create your t-chart, x plus h, ay plus k, and have something that ends at or ends up on 2 or 5, then you wouldn't be able to use it. So it's just nice to know that ahead of time, so you don't draw like this weird line and then you have to erase it and go back. So I know that my asymptotes are going to be x equals 2 and y equals 5. So if it's x equals 2, I'm going to go to where x equals 2. And remember, if we have a line that's called x equals 2, it would be a vertical line crossing the x-axis at 2 and going on forever. The same with y equals 5. So we'll go up 1, 2, 3, 4, 5. I do it with a pencil first because my eyes aren't that good and I know sometimes I'll lose track. Okay. So now we have where our asymptotes are. Again, a little squiggly. So now we'll have x plus h, which is x plus positive 2, x plus 2, and ay plus k. So that 1 times y is y plus 5. So I know that I want at least 3 points on one side and at least 3 points on the other. So remember, from the last page of our notes, we used, what did we use? We used -2, -1, -half, half, 1, and 2. So now -2 plus 2 is going to give us 0. -1 plus 2 will give us 1. -half will give us 1.5. Half will give us 2.5. 1 will give us 3. And 2 will give us 4. Then on this side, we had -half, -1, -2, +2, +1, and +half. So now -half plus 5 will give us 4.5. -1 plus 5 will give us 4. -2 will give us 3. 2 will give us 7. 1 will give us 6. And half will give us 5.5. So we can look at 0, right? We know 0 will give us 1, 2, 3, 4, and a half. 1 will give us 4. It's 1, 2, 3, 4. And then three. Oh, I knew that looked weird. I was like, why is that over there? That was -1. So +1 gives us 4. And then 1.5 will give us 3. So we kind of see that this line will go, or this butterfly wing will go in this direction. And then on the other side, because we skipped 2, we jumped to 3. 2.5, sorry, 2.5. So from 2.5, we'll get 5, 6, 7. 3 will give us 6, and 4 will give us 5.5. Still, my asymptotes don't touch my graph. It's just that my highlighter was kind of thick, so it kind of looks like it does, but it never really touches this line here at 5 or 2. Now, when we look for our x-intercept, we see that it does cross the x-intercept over here, right? This one will never cross x or y, but this one actually crosses x and y. So we need to find that, and the only way to find that is by using math, your favorite. So already we know that when x is 0, y is 4.5. So we already know our our y-intercept will be 0, 4.5. So the only one we really have to worry about is the x-intercept. So we're going to set y to 0. We're going to set y to 0, and we're going to say 0 equals 1 over x minus 2 plus 5. So the first thing we have to do is throw that 5 over with subtraction. So now it becomes -5 equals 1 over x minus 2. Now we don't want it in this x minus 2 in the denominator, so we're going to multiply top and bottom by x minus 2. And that means we have to multiply over here by x minus 2. Now we have 5x minus 10 equals 1. Now we have to add 10 because, again, our whole point is to get this this x by itself. Something looks wrong. Oh, sorry. This should be plus 10 because it's -2 times -5. All right. -2 times -5 would be positive 10. So we're subtracting 10. And that will give us 5x equals -9. And then we're going to divide it all by 5. So x will equal -9 over 5. So our x-intercept is -9 over 5, or 1 4/5, comma 0. And we see that that's about right when we look at our graph, that it's about like 1 4/5 if this continued to decrease steadily. That would make sense. Now, our domain here because it goes in one direction forever and the other direction forever is all real numbers. Where x does not equal, it will always have this part in the domain and the range because we have these asymptotes. So here, x will never equal 2, right? Because 2 is the asymptote where it approaches, but it never touches. Same with the range. The range goes up and down forever, except at 5, because it will never touch 5. Now here we are not increasing. We are swinging down here, and continuing to decrease. So we are not increasing. Remember that left to right. As we come from the left towards the right, we approach this asymptote and it curves downward. That's decreasing. Here, even though this arrow points up, as we move to the right, it swings down and continues to decrease. So we'll say we started at negative infinity to 2. Remember, because we're moving left to right, we go by the x-axis. Then we skip 2, and we continue on into infinity. Our rate of change varies. Our 1-to-1 is yes. Our horizontal asymptote is y equals 5, right? Because we should look at our k. And our h will give us x equals 2. Our transformations here, there's nothing going on with A, but we do have a vertical shift to the right 2 and a vertical shift up 5 and a horizontal shift right by 2. So for the x-intercept, we see that it crosses this x-axis. All we need to do is find out where. So it looks like it's between 0 and 1. So let's do the math and see if we're right. We'll set y to 0. We have 0 equals negative 3 over x minus 4. So we're going to add 4 to each side. We end up with positive 4 equals negative 3 over x. Multiply x over 1 to get it out of the denominator. And now we divide by 4. We end up with x equals negative 3/4, which looks right because it's between 1 and 0. So we'll have negative 3/4, 0. And y, we know that because y is here, the x equals 0 and the y-intercept goes, or the asymptote goes right through the y-axis, the y-intercept will never exist. So we say NA. Our domain, again, from left to right goes on forever. And we say all real numbers where x does not equal 0. Then our range, again, is all real numbers where y does not equal -4. So usually we have a decreasing interval, but here, because we have our vertical reflection, it's given us an increasing interval. So as we come from left to right, we're coming from the left, and as we approach this asymptote, it increases. So we're going to say that it's increasing from -infinity to the asymptote, which is here at 0. And it continues from 0, as we leave 0, here we're moving right from 0 all the way to the left, and it's coming up and increasing. So we're going to say that it continues from 0 to +infinity. Our decreasing interval, because we can only have one or the other, is NA. Our rate of change is always varies. Our one-to-one is always yes. And our vertical asymptote here is x equals 0, right? Because it has to cross through the x-axis, and it's a vertical line. And we look at our k, and we say our horizontal asymptote goes this way because k equals -4. So y equals -4 for our horizontal asymptote. Our transformations here, looking at our a, h, and k, we have a vertical reflection because we have -3, so our a value is negative. The absolute value of -3 is less than 1, so we have a vertical, it's the absolute value of -3 is 3. So our absolute value of 3 is greater than 1, so we have a vertical stretch. And we also have a vertical shift down because our k is -4. Okay, so now we have graphed two different reciprocal functions. And if you have any questions, please feel free to email me or ask Seb. And